Hello, let's look today at our third lesson for this unit, and that is graphing lines and inequalities. Hopefully most of the lesson today should be a review for you. Let's start by taking a look at some vocabulary. We have a slope, intercept, form of a line. This should be a very, very old topic to you. Slope, intercept, form of a line is an equation of a line in the form y equals mx plus b. I know you've seen that equation. Let's touch on a little bit of important information regarding that equation. We have two very important letters. We have m and we have b. So let's actually start with b. B, if you remember, is known as the y-intercept. But more importantly, this is your starting point. That's where you're going to start graphing each line. The other important piece is your m. Hopefully you remember that m stands for slope. And there's one very important fraction with some very important words that we think of when we think of slope. Hopefully you remember rise over run, because that is how we use slope. It is important that slope is always in that fraction form, rise over run. If you don't have a fraction, it's very easy to make a fraction, but it is necessary. So that's our first vocab word. Second one, horizontal line. Horizontal line has a couple of pieces to it. It is a line of the form y equals a number. Horizontal lines go left and right, and the slope is always 0. Now, if you notice that equation y equals a number, it's missing something. These equations have no x in them. They have only the letter y. And we have a nice little acronym that helps us remember everything about the horizontal line, and it is called HOI. H stands for horizontal. The O actually stands for zero slope. And the y means that y is the only variable in that equation. Let's take a look at vertical lines. Basically the opposite of what we just talked about. Vertical lines are a line of the form x equals a number, which means there is no y in it. These go straight up and down. And their slope is what we call undefined. We don't have a slope. We can't explain it when it comes to vertical lines. So just like horizontal lines have HOI, vertical lines also have an acronym, and that is VUX. V stands for vertical, U stands for an undefined slope, and X simply means that X is the only variable. So HOI and VUX are kind of your shortcuts to helping you remember horizontal and vertical lines. Let's look at our last two definitions. First one, x-intercept. This is the point where a line crosses the x-axis. One very important thing that we remember though, x-intercepts, y is always 0. Y-intercepts are the complete opposite. These are the point where a line crosses the y-axis, and x is always 0. Those are the two important things that you need to remember. If you're finding an x-intercept, y is 0. If you're finding a y-intercept, x is 0. So now that we have looked at several definitions, we're going to start applying all of this to graphing. Our first example, graph the following lines. If you notice, these lines are already in the form y equals mx plus b. That's a requirement to graph. It must look like y equals mx plus b. These two are ready to go. So we're going to do the first one together. You first need to know your starting point. This is your starting value. We are going to start at +1 on the y-axis. So we are going to go up 1 and put our starting dot. We are then going to use our slope. This is a fraction because and that's good, we need a fraction. What that says is we are going to rise a positive 1 and run a positive 2. To rise a positive 1, that means go up 1. And to run a positive 2, that means go right 2. Put a new dot at that intersection. Here's the nice thing about slope, it can be repeated. From the point we just made, we can again rise 1 and run 2. For many of you, it's sometimes easier to make a straight line when you have more than 2 points. Now, I am a stickler for straight lines. You may not freehand lines. You must use a straight edge. The easiest straight edge you can use is your ID. So pick up your ID and make a nice long line. Notice I did not just connect the 3 dots. I made a long line. And if you look at the end of my lines, I know they're small, but there are arrows there. Remember, you need to show me arrows at the ends of your lines because lines go on forever. So at this point, pause the video. You try part B on your own. Okay, let's see how you did. So part B, starting point, positive 2. That means that I am going to start up 2. My slope is a negative 3 over 4. Now, only the 3 is negative. So you need to rise negative 3 and run positive 4. So the way that we rise a negative is actually going down 1, 2, 3, and we still go 4 to the right. We can repeat that. Rise a negative 3, run a positive 4. And then hopefully you used your ID again and you made a nice straight line. And hopefully you got that one right. So these two were just to kind of refresh your memory about graphing. We're going to now turn to example 2 and you're going to notice they're a little more difficult. So if you look at both parts of example 2, these are not in that y equals mx plus b form. We need to make it look like that. In other words, we want to get y completely by itself. So let's look at A. To help you out, I'm going to put my little fence up. This right here is the letter that I want by itself. That will never move. So the first thing that does have to move is the 2x. To move the 2x, we need the opposite. That means subtract 2x. That leaves us with 5y equals. Now, 15 and negative 2x are not like terms. They cannot be put together. And if we look up here at our y equals mx plus b, we like x first and we like a whole number second. So I'm going to put the negative 2x first and I'm going to put the positive 15 second. Now to finish getting y by itself, we need to divide by 5. When you're dividing, you don't get to pick. We're going to divide all parts of the equation by 5. So we're left with y equals negative 2 over 5. Do not put that in your calculator to get a decimal because slopes cannot be decimals. It stays a fraction. The only question is negative 2 over 5 reduced? And the answer is yes. We cannot simplify that any further, so we leave it negative 2 over 5x. Now, 15 divided by 5, you can divide, and 15 divided by 5 is a positive 3. So now, these look like the problems we just finished. So let's go ahead and graph. We need our starting point. That will be the 3. So I'm going to start up, 1, 2, 3. My slope is negative 2/5. So that means from my point I started at, I go down 2 because it's negative, but I still go right 5 because it was positive. I can go down 2 because it was negative, I go right 5 because it's positive. And then I make a nice straight line. Okay, so your turn to try part B on your own. Go ahead and pause the video. Okay, let's see how you did. So we're going to put up our line. You should have moved the x part first by subtracting 3x. That should have left you with 2y equals negative 3x plus 6, just like our first example. Now you have to divide all parts by 2. We are left with y equals, is negative 3 over 2 reduced? The answer to that is yes. We are going to leave it negative 3 over 2x. 6 divided by 2 is a positive 3. So, hopefully you are now ready to graph. Your starting value is a positive 3 again, so I'm going to go 1, 2, 3 up. My slope is a negative 3 over 2. So from here, I'm going to go down 3, right 2, down 3, right 2. And make my nice straight line. So how'd you do? Did you get that one right? I hope so. So let's take a look at a couple more maybe challenging questions. So let's take a look at example 3A together. Put up our fence. Just like both parts of example 2, we need to move the x part. Subtract 3x from both sides. That leaves me with 1/2 y equals negative 3x plus 5. Now, we have a pesky little 1/2 there. If you remember back a couple of lessons, 1/2 fractions, not hard to deal with. We learned that if you want to get rid of a fraction, you use the reciprocal, or flipping it over. So I am going to multiply by 2 over 1, which will make all of that cancel. But if you remember, we have to do it to all parts. So I'm going to multiply the negative 3 by 2 over 1, and I'm going to multiply the 5 by 2 over 1. So I end up with y equals 2 divided by 1 times negative 3 is negative 6x. Positive 5 times 2 divided by 1 is positive 10. So let's get to graphing. Starting value, positive 10. So we need to go up 10 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way at the top. Now our slope, we have a little problem. It's a negative 6. We need a fraction. We need that rise over run. Anytime you have a whole number, if you remember, we always just put a 1 underneath it. So we need to rise a negative 6 and run 1. So rising a negative 6 means I'm going to go down 1, 2, 3, 4, 5, 6, and to the right 1. Down 1, 2, 3, 4, 5, 6, right 1. And let's connect it with our line. How'd you do? So go ahead and pause the video. You tried B, think about some of those other topics that we talked about earlier in this unit to help you out. Okay, let's see how you did. So this one, I said think about the other topics. The reason I mention that is because when you see parentheses, you know by now parentheses mean distribute. So you needed to distribute the 2. 2 times x is 2x 2 times negative 2 is negative 4. Bring down y minus 6 equals. That's half of your steps. If you look, y is not by itself. That says y minus 6. I need to get rid of the minus 6 with a plus 6. Now, I'm going to be smart though. That's a whole number. So the only whole number in this problem is the negative 4. That's where the plus 6 goes. So I am left with y equals 2x and negative 4 plus 6 is a positive 2. So let's go ahead and get to graphing. See how you did. Positive 2 is your starting point, so I'm going to start up, 1, 2. Your slope is a positive 2, but we need that fraction. So we're going to make it over 1, which means it's positive. I go up 2, right 1. Up 2, right 1. And connecting them with a nice straight line. And hopefully you got the right answer. So those were all of your y equals mxb kind of lines. Let's look at some different kind of lines now. So example 4, we're still graphing, but if you look at both of those equations, they are both single variable equations. When you only have one variable, you automatically should be thinking about our little acronyms, VUX and HOI. So when I see X, I automatically think, VUX. X is VUX, so VUX means vertical. We only need one point to make a vertical line. We just simply need to know where's it crossing. That is what this tells you right here. It's telling you it crosses the x-axis at 3. So here is the x-axis, and I'm going to go to positive 3 on the x-axis. So my vertical line, which means up and down, goes through that point right there. So I have enough information. All I have to do is draw my nice vertical line. And of course, don't forget your arrows. These are actually, in my opinion, easier than the other ones we just did. So go ahead, pause the video, you guys try B. All right, so how did you do? Let's see, when you see only Y, your other acronym you should think of is HOI. So we are looking for a horizontal line. We need to know where it crosses, which is that right there. On the y-axis, I need -2, which means down 2. And then I need to draw a nice horizontal line. Whoops, that's a little off. There we go, a little better. And your good old arrows. To me, like I said, I think these are easier. So now that we've seen y equals mx plus b, and we've seen vertical and horizontal, the last definitions we haven't seen yet are x and y intercepts. So this example, find the x and y intercepts of the following equations. So I'm going to organize my work a little bit. I'm going to do some labeling here. I'm going to find the x-intercept and the y-intercept. So the most important thing was that thing that I highlighted. If you are trying to find an x-intercept, if you remember, if you look back on that front page, we wrote down y is always 0. What that means is y is gone. Okay, if y is 0, it doesn't exist. So the part that contains the y, that part right there, it also is gone. So to find the x-intercept, I'm simply solving the equation -12x equals -54. And that's an easy equation to solve. If I divide by -12, I end up with y equals positive 4.5. So if you think about what we just did, not too hard, the y-intercept is just the opposite. If you remember, we highlighted the y-intercept, x is 0. So the part with x, this part right here, gone. So we are solving the equation 18y equals negative 54. Divide both sides by 18, and we get y equals a negative 3. So these two, whoops, I made a little mistake over here. This should not be y equals, that should be x equals. These are actually not together. These are two separate numbers that we are going to graph. The first one is telling us where to go on the x-axis. The second one is telling us where to go on the y-axis. So on the x-axis, I need to go to positive 4.5. So 1, 2, 3, 4.5 is in the middle. On the y-axis, I need to go to negative 3. This is the y-axis, which means I need to go down 1, 2, 3. So don't put them together. They are two separate numbers. Once you've drawn those 2 points, you pick up your ID, you connect your 2 dots. So at this point, you guys go ahead, pause the video, and you try B on your own. Okay, let's see how you guys did. So I'm going to organize my work the same way. X-intercept and y-intercept. So the x-intercept, the y part is gone. So 4 over 3x equals positive 8. That is a fraction. We know how to get rid of fractions. We know that we multiply by the flip. So 3 over 4. Do the same thing on the right side. So x equals 8 times 3 divided by 4 in your calculator leaves you with a positive 6. So let's look at our y-intercept. This time, the x part is gone. Now keep in mind, if this is gone, the negative is still there. So it is a negative 2y equals 8. Divide both sides by negative 2. We get y equals, and that's a negative 4. So here's our 2 pieces to graph again. So on the x-axis, I need to go to positive 6. So write 1, 2, 3, 4, 5, 6. On the y-axis, I need to go to negative 4. So down 1, 2, 3, 4. And then pick up your ID and connect those 2 dots. That's pretty bad. There we go. So that is x and y intercepts. Hopefully you got that question right. So at this point we are done with lines. We've learned all there is to know about lines. We learned y equals mx plus b. We learned vertical and horizontal. And we talked about x and y intercepts. Now we have a little more notes to take. We're going to talk about inequalities. So if you remember, the only thing that an inequality has that's different is it has a less than and greater than symbol. So there's a few extra rules that we're going to throw in here. So first step, put the equation in slope-intercept form. Again, that is y equals mx plus b. However, there is that very important rule that comes with less thans and greater thans that we talked about last lesson. And that important rule is if you divide by a negative, that symbol's got to get switched around. That's what we discussed last lesson. Once you've gotten y by itself, you graph the line the exact same way that we just graphed the first half of this lesson. Start with your b, or your starting point, and then use your rise over run. However, Once you have your points on your picture, we have to pause because you don't automatically draw the same kind of line we've been drawing. There are two types of lines. There are solid lines and there are dashed lines. Kind of like open and closed circles from the last lesson. You use a dashed line when you have only less than or greater than. If you have no bars, you must use a dashed line, and it's got to look dashed to me. When you have a bar underneath, less than or equal to, greater than or equal to, you draw a solid line. And there's one other little note I want to add here. Your line must touch two sides of the graph. These need to be very long lines. They got to completely touch two edges of your graph because we are shading. And if you draw a little bitty line, you can't shade properly. So we have two options for shading. We have shading up and shading down. Up, things are bigger. So when things are bigger, we are talking about greater than and greater than or equal to. When we are shading down, we are talking about things that are smaller, which are less than and less than or equal to. Now, all of these rules that we just wrote down on steps 3 and 4 about the symbols, dashed and solid, shading up and shading down, you are responsible for knowing those for the test. So now that we have all of our information that we need to apply it. We're going to do the first 3 together. You're going to try the last 2 on your own. So this first problem, we need y by itself. Just like the previous slides, I need to move the x. So I'm going to subtract 4x from both sides. And that leaves me with negative 2y. Keep my greater than or equal to symbol. X comes first, so negative 4x. Whole number comes second, positive 8. Now I have to divide. I'm going to divide by negative 2 under all 3 numbers. Now, we have y equals. We have that important rule. Did we divide by a negative number? The answer to that is yes. So we need to flip that symbol the other direction. Moving on, negative 4 divided by negative 2 leaves us with a positive 2x. Positive 8 divided by negative 2 is negative 4. So we have all of the information now to graph. So my starting point, just like before, is negative 4. So I'm going to start down 1, 2, 3, 4, put a dot. My slope, however, we got a problem. That's a whole number. Remember, if we get a whole number, we stick a 1 underneath it. So I need to rise positive 2, run positive 1. So up 2, right 1. I'm going to repeat it. Up 2, right 1. Now, this is where we have to make an important decision. This symbol in the middle of the problem is making all of our decisions. It has a bar underneath and it is less than. So let's look back at our rules. If we have a bar underneath, we have a solid line, and if it is less than, we shade down. So I need to make a solid line. That's the regular lines that we've been making. So use your ID. Remember, has to touch two sides. So I'm going to come all the way up here. There's one side. And then I'm going to drag it all the way down here. There's the other side. It must touch two sides of your graph. Now, the shading, I just got through saying we shade down. So let me show you what that means. From my line, I am going to go down. So if you notice, basically I am shading all of this region in here. That's what it means to shade down. Go from your line downward. So let's keep going. Getting warmed up. That was the first one. Throw a challenge one out there. So we have x is less than 5y. So to me, this one looks confusing. Looks confusing because the y is on the wrong side. Y has consistently been on the left side of the equation to start with instead of the right side. Well, that's an easy thing to fix. We know how to take a problem and flip it around. If I want the y on the right-hand side, on the left-hand side, I start with 5y. Now, if you look at my symbol, the open part faced the 5. So the open part has to still face the 5. Then the x goes on the other side. To me, that looks like all the other problems we solved. To me, that makes it easier. So to get y by itself, I need to divide both sides by 5. Here's where students make some mistakes. We have the y. Did we divide by a negative number? No. I'm going to keep my symbol the same. Common mistake here. What imaginary number is in front of that x right now? The answer to that is 1. The reason I put that 1 there is because the 5 is not next to the x. The 5 is underneath the x. The fraction is 1 over 5. Is 1 over 5 reduced? Yes. 1 over 5 is reduced. Now, to graph, to me, it still looks like we're missing something. What are we missing? We're missing the y-intercept. Well, that's an easy fix. If you are ever missing the y-intercept, it's simply always going to be a 0. Now that we have all of our necessary information, let's go ahead and graph. Our starting value is 0. I'm going to put a dot in the middle. My slope is positive 1 over 5. So positive 1 is up 1, 5 is to the right 5. 1 is up 1, 5 is to the right 5. Now, we got to figure out our line and our shading. My symbol here in the middle is greater than, but no bar. So let's look at our rules. No bar means dashed. Greater than means that we shade up. So when I draw my line, I'm going to use a dashed line. And remember, we touch one side, and then we go back and we touch the other side. My line is dashed to make sure that yours looks dashed as well. And we decided we are shading up. So if I go to my line and I go up, that means that I am shading this region of my graph. Okay, we're going to do one more together and then you're going to have 2 to try on your own. So turn the page to example 8. First of all, when I look at this problem, what do you notice? Hopefully you're thinking to yourself, we're missing a letter. You're absolutely correct. The only letter that we have this time is X. Anytime we only have one letter, it's either VUX or HOI. Since we have X, that means that this is a VUX problem. But to graph it, we still need that one letter by itself. We need X by itself. So to get X by itself, I'm going to divide by 3 on both sides. That leaves me with X is, did I divide by a negative? No. So greater than or equal to. 6 divided by 3 is 2. Now, we are ready to graph. This one we know is a vertical line. The only thing we need to know is what is the number that it goes through. It goes through X equals 2. So the x-axis, I need to go to positive 2 and make a dot. And then I am going to draw a vertical line right there through x equals 2. Oh, you know what I forgot to check? I forgot to check before I drew that line whether it was dashed or solid. Because this symbol has a bar underneath it, it was solid, so I got lucky. So we are good. This is greater than. Greater than is normally up. Well, greater than, we can't really go up from a vertical line. Really, our only options right now are either left or right. Well, greater than means bigger, and bigger is to the right, so I am going to shade the right side of that line. All right, so at this point we've done 3 together. I want you to pause the video, and I want you to go over to example 9 and 10 and try both of them on your own. Okay, let's see how you did. We need y by itself. Hopefully you subtracted, and I think of that as an imaginary 1x from both sides. That leaves me with negative 2y less than or equal to negative 1x plus 3. Okay, now we need to divide by negative 2 in all places. We are left with y. Did we divide by a negative number? The answer to that is yes. So that symbol now goes the other direction. Now this is where we can get a little tricky. We need to look at reducing this fraction. Negative 1 over negative 2. As far as the numbers go, they cannot be reduced. However, there are 2 negatives in that fraction. Anytime you have 2 negatives together in a fraction, they will always make a positive 1 over 2x. Now the y-intercept, 3 divided by negative 2 is not a whole number. However, you can use a decimal for the y-intercept. So it is negative 1.5. And we are ready to graph. Let's take a look at our starting point. Negative 1.5 means down 1 and a half. Now our slope is positive 1 over 2. Be careful. If you are in the middle of a box and you go up 1 box, you are still in the middle of a box. So that is up 1, right 2. Up 1 in the middle of the box, right 2. We need to know dashed or solid and which way do we shade. So our symbol is right here. I see a line underneath, which means solid, and I see a greater than, which means up. So I am going to draw a solid line touching one edge of my graph, and then coming over here and touching the other edge. And then I am going to shade up. And we are done. How'd you do? Did you get that one right? Hopefully so. Let's take a look at our last example that you should have tried on your own. We need to start by getting y by itself. I need to move my x. I'm going to subtract 3x from both sides. Notice I put it underneath the other x. I have 2y greater than or equal to. Now, what's 3x take away 3x? 0. It's gone. We are left with just a negative 8. So look at what we have there. Hopefully you noticed very quickly that the only letter we now have is y. And so y we think of void, which is absolutely correct. So let's finish solving. divide by 2. We get y. Did we divide by a negative? No. So we keep the symbol the same. Negative 8 divided by 2 is negative 4. So since we are making a HOI problem, which is horizontal, I simply need to know, where does it touch? Well, it touches right there. On the y-axis, I need to go down 1, 2, 3, negative 4. And I need to figure out, do I have a dashed solid and which way do I shade? So here is my symbol. I have a line underneath, which means it's solid. And because it's greater than, I shade up. So solid horizontal line. With arrows, of course. And then I need to shade up. And hopefully you got that one right as well. So we are done with the lesson for today. You are more than welcome to start on your homework if you would like. And you will keep in mind to have about 30 minutes in class to work on it next time I see you.